Alright, thank you for watching this video and make sure to subscribe my channel and I'll see you on the next one. Thanks and cut!
That's a wrap! Oh, welcome to the video tutorial of the applications of circles.
I got it! Alright, if you're a student and you're studying circles in pre-calculus but you are kicking and screaming because it has no importance to you, well, stay tuned. Hey! So today, I was gonna show you what is the application of circles in real life and its importance to us. And I promise, it's gonna be simple, easy, and fun. If you keep an eye out, you can easily notice how about the circles in our everyday life. Let's go! So circle by definition is a set of all points in the xy plane that are fixed distance r from a fixed point hk, where radius is given by r and the center is given by hk. So I want to show you the equations of the circle. This is what the equation looks like if the center of the circle is at the origin or is at the point 0, 0, where the equation is given by x squared plus y squared is equal to r squared, where radius is any distance from the center of the circle to any point at the edge of the circle. At the right side, this is what the equation looks like if the center of the circle is not at the origin or is not at the point 0, 0, where the equation is given by x minus h squared plus y minus k squared is equal to r squared, where the x coordinate is given by h and the y coordinate is given by k. So remember, a circle is a conic section because given a conic section, if a plane passes through the conic section horizontally, it will form a circle from the conic section that is cut by the plane. So before we go to the real-life application of the circle, first let me give you the standard equation of the circle given by x plus 2 squared plus y plus 1 squared is equal to 16. So first, we need to find the center of the circle, which is given by h and k. So as we all know, the x-coordinate of this equation is positive 2. Remember, in getting the center of the circle, it should be the opposite sign. So if this is positive 2, it will be negative 2. Now, in the y-coordinate, if this is positive 1, it will be negative 1. So we have the center. Now, the second is finding the radius. So, in this equation, it is 16 r squared. Now, to get the radius, r squared is equal to 16, we should square root it. So the square root of 16 is 4. So the distance from the center to any point at the edge of the circle is 4. Now, we need to plot the center and the radius. So for the center, it is negative 2, negative 1. So, negative 2, negative 1. That is the center. Just negative 2 and negative 1. Now the radius, you need to count from right, top, left, and bottom. Then 1, 2, 3, 4. This will be it. Then up. 1, 2, 3, 4. This will be it. Then 1, 2, 3, 4. Have the left and the bottom. 1, 2, 1, 2, 3, 4. This will be it. Now, if you have all the coordinates, you need to trace it. So here, from here, then here, and here. So, after tracing it, you need to name it. So it is 1, 2, 2, negative 1. And this one is 1, 2, 1, 2, 3, 4, 5. This is 2, negative 2, negative 5. This one is 1, 2, 3, 4, 5, 6, negative 1, negative 6, negative 1. Then 1, 2, 1, 2, 3. So negative 2, 3. Now, you have the circle, which is given by the equation x plus 2 squared plus y plus 1 squared is equal to 16. So for our second example, given by the equation x squared plus y squared is equal to 9. So first, we need to find the center. As you can see here, there is no x coordinate or y coordinate, so our center will be at 0, 0 or at the origin. And then the second one, we need to find the radius given by 9, which is r squared. So the radius r squared is equal to 9, and then square both sides. You will have 3 units. So now let's plot the points. You have the origin at 0, 0 here, and you have the radius, which is 3 units. 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. And all you have to do is trace it. Here you have it, and then plot it. 3, 0, and negative 3, 0, negative 3, then 0, 3, and then negative 3, 0. And there you have it. You have your circle as the equation x squared plus y squared is equal to 9. The importance and applications in real-life circles is that the circle is the basis for the wheel, which with related inventions such as gears. In mathematics, the study of circle has helped the development of geometry, astronomy, and calculus. Examples of these are the wheels, Ferris wheels, pizzas, and semicircular tunnel. So now, let's move on to the real-life application of circle. Now the given problem is a highway with 2 lanes, each 10 feet wide, goes through a semicircular tunnel with a radius of 12 feet. How high is the tunnel at the edge of each lane, round up to 2 decimal places? So now we need to visualize the problem. First, we need to draw a coordinate plane, which is here, the coordinate plane, and the 2 lanes, which is here, the highway, and the tunnel. It is said that the 2 lanes each have 10 feet wide. So here's the 10 feet and the 10 feet. And the tunnel is semicircular, so we need to divide it by 2, as shown here, and it has a 12 feet radius. Now, it is said that how high is the tunnel at the edge of each lane? This is the edge of the highway. It is said that how high is this from the tunnel? So we need to find this. So the problem is plotted at the origin, so we need to use the equation x squared plus y squared is equal to r squared, where r squared is given by the width and the y squared is given by the height. So x is 10, so it will be 10 squared plus, we don't have the height, so y squared, and the radius is given by 12 squared. So it becomes 100 plus y squared is equal to 144. Then transpose 100 here, so it will become y squared is equal to 144 minus 100 to isolate the y squared, because this is you want to find. Then y squared is equal to 144. Oh, sorry, 44 only. Then square both sides. Y is equal to 2 square root of 11, or y is equal to 2 times 3.31. Then multiply the 2 times 3.31, you will got 6.62 feet. Now, this is the answer. Now, the height of the tunnel at the edge of each lane is 6.62 feet. Now, for the second real-life application of circle, given by a seismological station is located at 0, -3, 3 kilometers away from a straight shoreline where the x-axis runs through. The epicenter of an earthquake was determined to be 6 kilometers away from the station. So the first question, find the equation of the curve that contains the possible location of the epicenter. B. If furthermore, the epicenter was determined to be 2 kilometers away from the shore, find the possible coordinates, round up to 2 decimal places. So for the first question, find the equation of the curve that contains the possible location of the epicenter. So It is said that the seismological station is located at 0, -3, which will be our center. And the epicenter is 6 kilometers away. And this will be our radius. We can derive this to the equation x squared plus y squared is equal to r squared, where our x coordinate is 0, so it will stay the same, and our y coordinate is -3. In plotting this, it will be the opposite, so y plus 3 squared is equal to, which is our radius, 6 squared. And this represents the equation. So for the second question, if furthermore the epicenter was determined to be 2 kilometers away from the shore, find the possible coordinates. And we have our equation x squared plus y plus 3 squared is equal to 6 squared. And the epicenter was determined to be 2 kilometers away from the shore, so we will replace y by 2. So our equation will become x squared plus 2 plus 3 squared is equal to 6 squared. So we need to find the x. So we will transpose 2 plus 3 squared here. So minus 2 plus 3 squared. And then solve this and this. It will become x squared is equal to 36 minus 25. Then x squared will become 11. So we need to find the x. So we need to square both sides. X is equal to positive or negative 3.32. Now, to find the y value, just substitute this x squared by x squared is equal to 11 by here. So 11 plus y plus 3 squared is equal to 6 squared. And then transfer here to this. And then y plus 3 squared is equal to 6 squared minus 11. And then y plus 3 squared is equal to 25. Then square both sides. Y plus 3 is equal to 5. Then transpose it here to get the y. Y is equal to 5 minus 3. Y is equal to 2. So there you have it. You have your x and you have your y. 3.32, 2, and negative 3.32, 2. I hope you learned a lot from this tutorial. So if you have any comments and suggestion, comment it below. I hope you enjoy a lot, and don't forget to subscribe. Bye!